Welcome back to part 2, mapping spatial data in R. So at the very end of part 1, we started using the QTM function to do a quick T-map, but now we're going to take that a step further, and I'm going to explain how we create some more advanced maps and do some customization as well. So first up, we have these things called scripts in R. So far, we've been getting you to type the code in the console, so the bit of the window on the left-hand side. And so you type in one line, press enter, and it does something. And that's great. But when the commands you use get more complicated, you have more lines, you have multiple lines of code, we have these things called scripts. And so this is where you can write out several lines of code and then run it as a block. And so run these lines all at once. It's really, really useful because it makes it a lot easier to correct code, particularly when you've got multiple lines. It allows you to run sections of code all at once, either subsections or the whole thing if you want to. And if you set up your script correctly, what you can do is you can use it as a kind of, this is where you got to in your analysis. And then when you open up R the next day, open it up, and you can rerun the script and it will take you back to the point you were at the bottom of the script. So they're a really, really useful tool, and I'd really recommend everybody use them from now on. In our original R Studio window, we had 3 sections, and so we've got a new one now, this one on the top left, and this is where you write the scripts in, and you'll notice the console has gone down to the bottom here. So once you've been doing a bit of work, you might end up with something a little bit like this. So in the top window here, we have our scripts. So you can see the one's called script multiple maps.r, and there's various bits of code in here, and then the console. And then how we actually run scripts, we can select a chunk of lines, so highlight them, and then press the run button up here. Another option is to use Control and Enter, so highlight the lines you want to run, then hold down Control and press Enter on the keyboard. And what R essentially does is it takes each line of code and pastes it into the console, and you'll see this happen as it does. And then it will generate any output that it does. So for example, it's generated a map here. If there are any errors or anything, you'll probably see some red text come up. That could be an error, could just be information. Unfortunately, R will just kind of plow relentlessly on through your script. So even if you do get an error, it will carry on. And that will probably give you another error, and they kind of all compound together. So if you do get loads of red text, don't worry. Go back up, see where the first line was, see what the problem with that line was, and correct that if you can. When you're troubleshooting, you can also go through, or what they call step through code. So do it one line at a time and see if it does what it's supposed to. And RStudio is really helpful with that because you can run one line of code, Control and Enter, and then it will automatically move the cursor to the next line. So if that's gone okay, you can run it again. You just press Control and Enter again. Or if you're lazy, you can hold down Control and just press Enter, and it will run each line of code. So press Enter, it'll run a line, press Enter, it'll run a line, and so on. And so that's a useful way to go through the code and see what's happening with it. One other concept that I wanted to talk about is joining data. And this is key to working with any data in GIS. And it's particularly key in working with data in R as well. So for example, we might have some spatial data. Sorry, let me go back. So imagine we have a table of data. So this could be a CSV table, it could be an Excel table, anything like that. And so we have this area ID column on the left here. And so this could be using names or numbers to uniquely identify each area. These areas could be countries, they could be counties, they could be output areas, they could be LSOAs, any number of different types of areas. And then we might have one or more columns of data. So for example, we've got 2 columns there, deprivation and population, but we could have like 10 columns. There's no limit on how many columns we have. And the data could be categorical, it could be numeric, it could be any sort of data. So you see we've got high, average and low here for deprivation. We've also got some population numbers as well. And I'm sure you've seen tables of data, this sort of thing before, that you've used with your own work. The key bit with joining is we also have some spatial data, so what we might call polygons or a shapefile with these areas identified. And so we'll have a list of areas as well within the spatial data. They could use numbers, to identify themselves. They could use names, so it could be countries, it could be counties, it could be any kind of geography you want. As long as those names match, so the list of the names in the shapefile and then the list of the names in our data, as long as they're the same, so we can get the computer to match these together, to join these together, or to, sometimes we might say, merge these together. Join is more common in GIS lingo and merge is more common in R lingo. So we end up using both. And the computer can do that join for us very easily. So it can look down the list and say area 1, area 1, area 2, and so on. And this allows us to get some data into our GIS. And ultimately, this allows us to create a choropleth map because we can color the areas by what category they're in. So for example, area 1 is high level of deprivation, area 4 is average, and area 7 is low. And so we can create something like this, where we have our map colored depending on the data. So, deprivation in this case. And this is where we start to get the power of spatial data, because you can see we've got a cluster of high deprivation up the top here, 1, 2, and 3, and then areas of lower deprivation along the bottom of this map here, 7, 8, and 11. So you can start to see how it's coming together now. The biggest important thing here is that the attribute, so these are called attribute joins. An attribute is a bit of text that we're matching, so the name or the code. Those must match exactly. So between the spatial data and the table of data, they have to match exactly. And because it's the computer doing it, exactly doesn't mean pretty close, it means exactly the same. So for example, with our line here, if we had it in one data set as Gambia, the, and then in the other data set as the Gambia, those are different. As far as the computer is concerned, that's completely different and it will not match those. Equally, USA is not the same as the United States. Equally, UK is not the same as Great Britain. So these must match exactly. One situation that does occur occasionally is you see this bottom example here. You see we've got UK does not equal UK. But if we look closely, the second UK, there's a space there. You see it just before the quote mark. Sometimes that does happen. And if your join doesn't work, sometimes this is the issue. And this can be quite a pain to spot because it's not that obvious, but it's something to have a look for if your join isn't working. One other aspect is that sometimes a data will provide names and codes for particular geographies, and these codes can be really, really useful. So for example, there's what we call ISO 3 codes for countries. And these are 3-letter codes that are internationally recognized to represent a country. And sometimes joining the code rather than the name can be really, really useful. This is a great tweet. People have many, many issues with data, and often this kind of issues with text is one of the key ones. So here they've got Ivory Coast data, or Coast Ivory, and these two data sets won't join because the name's not identical. Because when the data's been copied or reformatted, it's lost some of the characters. So the O with the little hat has disappeared. So that and that won't match. But if we use the ISO codes, it will still match because they're the same, CIV. So sometimes these codes can be really useful. And this is not a thing that's restricted to kind of international data or unusual places. Even names in Ireland have these fadders. So for example, little ticks above the A, an L, an E, and so on. So this is a problem that can happen anywhere. One other important aspect of when we're creating these choropleth maps is how do we choose which colors and which classes to put the data into. So for example, we've got some nice data here, age 0 to 4, number of people. And we've decided to split it into 6 categories, and we've decided these are the categories, and we've decided to use these colors. So how do we think about that? The colors are really important. How you choose the colors is quite important because it can influence what the map looks like. There's a whole area of color theory and map design and cartography and so on and so forth, which I'm not going to go into now. one of the key bits is we need to think about who's using the map and what they're going to do with it. So I first of all think about the output. So is it going to be shown on a computer monitor? Is it going to be shown on a projector? Is it going to be printed out in color? Is it going to be printed out in black and white? All of those different options have different colors, selections of colors that they can show. Black and white photocopying being another obvious example. And there's a great website called Color Brewer, which was developed by an academic, Cynthia Brewer, from the US. She did a lot of research into color perception, all that kind of stuff. And they suggest colors for choropleth maps that allow the different classes to be distinguishable. Do have a look at that. And Color Brewer will crop up when we use R. So you'll see reference to it when we're dealing with some of the work we're doing. Equally, color blindness is quite important, which is what the user bullet point is there for. So color blindness is when people can't perceive certain shades of colors. It's relatively common, affects about 1 in 10 men, 1 in 100 women or so. And red-green color blindness is the most common. So this is where shades of red and shades of green look the same. So it's a good rule of thumb to avoid using shades of red and shades of green in the same map. If we wanted to do something above or below a mean or above or below a certain value, we'd often use red and blue in that case. Equally, choropleth maps has classes, so these actual categories. Now, how do we choose those? It's important because the same data classified differently can look very different. So this is a great example. So we've got 3 maps here. They're showing exactly the same data, but with different categories. So we can see some quite different spatial relationships in these maps. So this one in the middle, quantile, we seem to have a lot more cases, I would say, than looking at any of the other 2. Even though the data is identical, it's just how we decided to classify it. A nice way of thinking about it is thinking about the histogram of the data. So for example, up the top here, this is equal interval. And this is a histogram of data. So the histogram's the same shape throughout because it's the same data set. Equal interval looks at the range of the data and divides the data up into a certain number of categories, each the same size. So for example, now we can see we've got 10 to 20, 20 to 30, 30 to 40, and 40 to 50. So our interval is 10, and it's equal throughout all the categories. Another approach is quantiles. So that puts the same number of data points in each category. So for example, up here, we've probably got the first quarter, first 25% of the data, then we've got the second quarter, then the third quarter, and then the fourth quarter. So you can see this shows more variation on the map. We've also got this one at the bottom called natural breaks. And this is an algorithm is used to define the categories. So it's based on the k-means clustering algorithm, but what it tries to do is to group similar data together. So if you've got some kind of natural clusters in the data, it should be able to pick those out. As a starting point, I'd recommend natural breaks. It's sometimes referred to as Jenks or Fisher, and Jenks and Fisher were the 2 academics who came up with the process in the first place. And R can do all sorts of different categories. So we've talked about equal intervals, quantiles, natural breaks already. Standard deviation uses the data to define the categories. So you can have it as the mean as the midpoint of the data, and then plus or minus 1 standard deviation of 1 category, 2 standard deviations of the next one, and so on. Jenks is the same as natural breaks. There's a minor difference between Jenks and Fisher in R in terms of how it's actually calculated, but for practical purposes are the same. And lastly is unique, and that's R's term for you set the categories. So you can say what you want them to be. We can visualize this in R. So for example, we can have a histogram of data, and then we can think about how it's been divided up. So we can plot these lines on to show these divisions. And that can be really useful because we can see, this is our map example here, and we can see the categories. We've got one at 6 there, 41, 72, 99, and so on. And so we can visualize this. Some GISs give us nice interactive histograms where we can drag these bars around, these lines, to update the map. R doesn't do this, but we can replicate this. So for example, we can extract the variable we want to show, so age 0 to 4 in this case. We have to load a library called classInt. We can calculate the breaks. So this is where we actually calculate the groupings. And you can see we say how many we want. So n equals 6 tells us we want 6 breaks, and the style is whatever style we want to show. So we've used Fisher here. Very quick side note, we've got when you type this into the console, you get 2 slightly different outputs. So if you just type in breaks, that will give you the whole thing. So there's some extra bits of information here, what the style is, how many different combinations there are, the upper and lower bounds, and the number of points in each group, which might be really useful. However, for a lot of the work, we just need the upper and lower bounds. So if you do breaks $BRKS, it will give it to you in this simplified form. And we need this for some of the work we're doing later on. So we actually plot the histogram, and then we use this function AB line, and we can say, draw these lines at these breakpoints. So this breaks $BRKS, and we've set it as red for this. So do have an experiment with that in R when you get to that point. Lastly, I just wanted to add a couple of useful hints and tips. So if you're typing stuff in the console, if you press the up arrow on the keyboard, it will show you the previous command. There's a history tab that contains a history of all the commands you've typed, which sometimes can be quite useful. The plot window on the bottom right has a back arrow, so you can go back to previous plots if you want. And there's also an export option there, so you can click export and it'll save it as a file. There are other ways of saving maps as well, and we'll get to those later on. Tab completion is really, really useful. It's one of these things where you start typing either a function or a variable in, and R will suggest what it thinks you're trying to type, and that can be really, really useful. So start typing, press tab, see what comes up. One thing's always worth remembering is if a function's not working or it's not doing what you expect, try reloading the libraries. If it's saying it can't find a function, you've probably forgotten to load the libraries. So make sure you run library SF and library tmap. The error messages that R gives sometimes can be really, really cryptic. Unfortunately, that's just how it is. Do remember they're case sensitive. So make sure you've got your capitals and lowercase right. R is very picky about commas and brackets. Have you got the commas in the right place? Are you using the right sort of brackets? Have you closed all the brackets you've opened? And it's also very, very susceptible to typos. So if you get any error messages, try and look for those 3 things. Some very common error messages, for example, might be this one: error in getinfo.shape, error opening shapefile. That means it can't find the shapefile. Odds are you don't have the working directory set correctly. So it's looking in that working directory for that shapefile and you can't find it. The shapefile must be in that folder. It can't be in a subfolder. So if it's in a subfolder called data or shapefile or whatever, put it in the main working directory. If you get something like this, error could not find function, stread, or whatever function that it's trying to do, that means it doesn't know where that function is. It probably means you haven't loaded the library. So try loading the library that function is in. Do have a look at the glossary and feel free to send in suggestions for things to add to that. One other thing, if you've been typing in some stuff in R and it's something you do in a thing, check what is shown in the console. Here we've typed in 1 + 4 and it's given us 5 times 90, which is fine. But then we've typed in 5 star for times and then press enter. And it's come with this plus symbol instead of this greater than symbol. So R is saying you haven't finished the command, finish the command, otherwise I can't run it. So if you type in 90 or whatever number, press enter, it will run the command. If it's come up like that and you don't really know what's missing, try doing a comma or a closed bracket or something like that. It will probably give you an error message, then you can go back and try again and see what the problem was. Okay, so part 2 is below. Have a go through the workbook, go through the commands, same as before. There are some optional exercises, so if you want to have a go at those, please do. If you want to skip them, that's fine as well. Do remember to type out the code. It does help with the learning process. But in this part, there are a couple of long chunks of code. So if you want to copy and paste those, then you can do. But generally do type it out. It does really help. See you for part 3.